Which of the following contains the greatest mass of aluminum? 122 grams of aluminum phosphate, 266 grams of aluminum Al2Cl6. That's not really aluminum chloride. I think it's some made-up compound it might be a compound, but chemical formula to, test us and such. Um, Why is it a compound? Well, it might be a molecular compound of some sort, but generally aluminum is a metal and it's going to be making an ionic compound. And if that's an ionic compound, the simplest chemical formula would be AlCl3. AlCl3, aluminum chloride, is a compound, yeah, but Al2Cl6, that suggests that it's some sort of molecular scenario. Or aluminum sulfide, Al2S3. Okay? So, if I take the grams that they provide of aluminum phosphate and use the molar mass of aluminum phosphate and identify that that's how much mass is in 1 mole, then I convert moles of aluminum phosphate, identify how many moles of aluminum there are per mole of aluminum phosphate. There's just 1 aluminum and 1 aluminum phosphate, right? And then I can go from moles of aluminum phosphate to grams of aluminum phosphate. All right? Okay, so they gave me the mass of 1 mole of aluminum phosphate. That means I have 1 mole of aluminum. That's 26.98, which is on the periodic table, right? 26.98 grams per every mole of aluminum phosphate. In this scenario, they gave me 1 mole of material as well, but 1 mole of material here has 2 moles of aluminum in it. And so the mass of aluminum is going to be 2 times the 26.98. Let me get out my calculator and do that one. 26.98 times 2. Okay, good. 53.96. And in the third scenario, it's aluminum sulfide. Let's just double check here. Molar mass of aluminum sulfide. So that is 150.98. Let's double check the Al2S3. Yeah. So here we have 225 grams of it, so it's more than a mole. 150.158. So we start with 225 grams of aluminum sulfide, and we want to know how many grams of aluminum there are in there. Well, I have more. I know that this is going to be the answer, don't I? Because I have more moles of aluminum sulfide than I do of the other ones. But we can double check here. I need to go from grams of, oh, they're missing an L there, grams of aluminum sulfide to moles of aluminum sulfide. Why do you go to moles? Well, these compounds are expressed, their ratio of atoms within the compound are expressed in moles, and so that's why we go to moles. Okay, it's a way to use the stoichiometry of that chemical. All right, so 150.2 grams for every 1 mole of aluminum sulfate, and then a mole of aluminum sulfate has 2 moles of aluminum. And then I can go from moles of aluminum to grams of aluminum, and that is the 26.98 again. So 225, but this time I only divide by the 150.2 times 2 times 26.98. So there's 80.83 grams of aluminum in that scenario. So for the first two, we had, where are we at? We had 26 grams, 53 grams, and then 80 grams. So determine which following contains the greatest mass of aluminum. It's the third one. All right. Now, you might have thought, well, why don't we just go off of mass? right? Well, obviously we can't go off of mass because they have different molar masses. Uh, Once we saw that this was a higher mass than this material, but a lower molecular mass than this one, that gave us the indication that this is going to have the most amount of aluminum. Okay, good. So number 26, diamond is one form of a carbon. An engagement ring contains it might contain, not all specific one, contains 1.25 carat diamond in it, which is 200 milligrams. How many atoms are present in the diamond? 200 milligrams of carbon. That's right. It's all carbon. So it's 200 milligrams of carbon. All right. I'm going to go 0.2 grams. Is that okay? Was it 200 milligrams? Yeah. I'll go 200 milligrams down here. I'll do it twice. But I knew in my head that 200 milligrams is 0.2 grams, and that's where we want to eventually get. But we're looking for, what are we looking for? Atoms of diamond, of carbon. That's right. So we're looking for atoms of carbon. So if I have that many grams of carbon, I can go from grams of carbon to moles of carbon. And then I can go from moles of carbon to atoms of carbon. Here I can go from milligrams of carbon to what? You want to go to grams. That's right. I need to go to grams here, grams of carbon, because then I can go from grams of carbon to moles of carbon. And then where? Moles to atoms. Good. Moles of carbon to atoms of carbon. That's where I want to be, atoms of carbon. All right. Do you know how many atoms of carbon there are in a mole of carbon? That's Avogadro's number, right? Yeah, it's 6.02 times 10 to the 23rd. All right. And how about how many grams per mole? That's 12. 12 grams per mole. That's on the periodic table, right? How about this one? Milligrams per gram? 1,000 milligrams per gram. 1,000 milligrams per gram. Good. Okay. So both of these should give me the same answer here. So we got 0.2 divided by 12 times 6.02 times 10 to the 23rd. So I'm getting 1 times 10 to the 22. Okay, good. Number 27. A Cullinan diamond was the largest natural diamond ever found. It weighed 3,104 carats. Uh-oh. Did I make a mistake in the previous one? I did. Look, 1.25 carats. This is not saying that 1.25 carats is 200 milligrams. It's saying that we started off with 200 milligrams and we have to convert 1.25 carats, we have to convert that to milligrams. Oh, brother. Yeah, so we have to go back one step here and say that if I have 1.25 carats and 1 carat is 200.2 grams of carbon. So 1 carat of carbon. So 1 carat of carbon is 200 milligrams, but I started with 1.25. So these numbers here times 1.25. So it's 1.25 times 10 to the 22nd. Okay, good. Number 27. The Cullinan diamond was the largest natural diamond ever found in 1905. How interesting, huh? That's cool. And it weighed 3,104 carats. So I'm told that it was 3,104 carats. And I would like to know what? How many carbon atoms? All right. How many carbon atoms? Well, they tell me a conversion factor from carats to what?
To milligrams.
To 200 milligrams of carbon. So 1 carat of carbon, I guess I can call that CAR to be less confusing. And now I can go from milligrams of carbon to grams of carbon.
1,000.
Good. And then I can go from grams of carbon to a mole of carbon, right?
That's 12.
12 grams per mole. And then I can go from moles to where?
Atoms. Atoms of carbon.
Good. And how many atoms are there per mole?
That's Avogadro's number, right?
Yeah, 6.02 times 10 to the 23rd atoms of carbon for every mole. Okay, so 3104 times 200 divided by 1,000 divided by 12 times 6.02 times 10 to the 23rd. All right, 3.11 times 10 to the 25th. Okay, good. So 28, 155-gram serving of a particular cereal gives 270 milligrams of sodium, 11% of the recommended daily allowance. Okay, and then how many moles and atoms of sodium are in the recommended daily allowance? Well, 270 milligrams is how many were provided. Yep.
Yeah.
And I would like to know how many what?
Atoms of sodium.
Okay, I'd like to know atoms of sodium. Okay, and so I can go from milligrams of sodium to where?
To grams.
Good. Milligrams of sodium to grams of sodium. And then what?
Grams to moles.
Grams of sodium to moles of sodium.
And then moles to atoms, right?
Okay, moles of sodium to atoms of sodium. That's pretty easy, right?
Yep.
And then I got 1 gram is 1,000 milligrams.
Yeah, and then 1 mole is 23.5, is that right?
I think it's just 23.
Oh, let me see. Oh, yeah, 23 grams.
Okay, so 23 grams of sodium for every mole of sodium. And then I go moles of sodium to atoms, so that's Avogadro's number, right?
Yeah, 6.02 times 10 to the 23rd.
Okay, very good. Now, this is my answer, and that's how many atoms of sodium there are in 270 milligrams. So we'll do that really quick. 270 divided by 1,000 divided by 23 times 6.02 times 10 to the 23rd. All right, so that's how many atoms of sodium are in what?
270 milligrams.
That's right. And is that the question they're asking?
I guess you're saying it's not?
Let's see. Let's do right number of significant figures times 10 to the 21 atoms of sodium. They're asking how many moles and atoms of sodium are in the recommended daily allowance. So I guess we found out how many atoms there. We have to divide by 6.02 times 10 to the 23 to get to moles. Or in other words, if we wanted to stop at moles here, or sorry, moles of sodium, if we wanted to stop at moles of sodium, we would have stopped right there. So we just do 270 divided by 1,000 divided by 23. And that gives us how many moles? So 0.0117 moles of sodium. Okay, so I have atoms of sodium and moles of sodium there. But that's in the 270 milligrams, and what are they after?
Oh, they want to know how many in the recommended daily allowance?
That's right, the RDA. So If this represents 11%, then we can identify what 100% would be by doing this. 0.11, 0.011, no. Yeah, we'll do moles first. 0.0117 moles of sodium in 11%, and we want to know how many it would be in 100%. So if we go 0.011 moles is the amount for 11%, and we don't know how many moles are needed to have for 100%, but this ratio should give us our answer. So if I take my 0.011, times it by 100, and then divide by the 11, that tells me that 0.1067 or how many significant figures?
3. Oh no, 2.
2 significant figures, right? So 0.11 or 0.11 moles in the recommended daily allowance. And then divide that by 6.02 times 10 to the 23rd. And that gives me 1.7 times 10 to the minus 25. Oh, no, times it by. Sorry, we want to times it by. So we want this, because that is how many there are, and I want to know how many there are per mole. So times by 6.02 times 10 to the 23rd. So 6.4 times 10 to the 22nd. That is how many atoms are in the recommended daily allowance. Okay, good. A certain Nut Crunch cereal contains 11 grams of sugar per serving, size of 60 grams. How many servings of the cereal must be eaten to consume that many moles of sugar? All right, so how many serving sizes of 60 grams must be eaten to get 2.78? So what do I want? What's to the right of my equal sign?
Servings?
That's right. I want how many servings. And what am I trying to get those servings to provide for me?
The moles of sugar, the 0.0278.
Good, 0.0278 moles of sucrose. Okay, C12H22O11. So each serving size gives me 60 grams of sugar. And there are 11 grams of sugar. Let's see, a certain nut crunch contains 11 grams of sugar per serving size of 60 grams. So there's a conversion factor there provided for us. 11 grams of the sucrose for every 60 grams of cereal. Okay, and I have moles of sucrose. I need to go from moles of sucrose to get to grams of sucrose. And then I can go from grams of sucrose to grams of cereal. And then 11, let's see, a serving size of 60 grams. Oh, 60 grams of cereal is one serving. And there's 11 grams of sucrose for every 60 grams of cereal. And sucrose, didn't we find out it was 360 or something like that? Let's double check here. What's the molar mass of sucrose?
According to Wikipedia, Wikipedia. Sucrose, a disaccharide, is a sugar composed of glucose and fructose subunits.
Okay, so we got 0.0278. That's how many moles of sucrose. And if I multiply that by 342, that gives me grams of sucrose. And then there's 11 grams of sucrose for every 60 grams of cereal. So how many 60-gram units are there? I can get that by dividing by 11 and timesing by 60. And then I can divide by 60 again, because I'm going to call that a serving.
Could you have just said one serving contains 11 grams?
That's right. I could have just used this serving and said that that contained 1 gram, just the same as dividing and multiplying by 60. Okay, so 0.864 servings let's see, did I do that right? 0.27 times 342 times 60 divided by 60. 0.864 servings. Does that make sense?
I guess so, for only 0.0278 moles of sugar.
That's right. Good job.